Hello class and welcome back to another segment of Sketch Science. Today we are going over Galileo and his discovery of Jupiter's moons and how it helped us to realize how gravity orbits work and also how we figured out how we were not the center of the solar system. Now, Galileo, this name probably sounds familiar to you. He's fairly famous in astronomy and science because he was the first known person to use a telescope. A telescope. What is a telescope? Well, telescopes, you could simply say it's a tube that lets you see far away. But what they really are is it's a combination of lenses and mirrors and different things. Telescopes can be very complex, and its job is to either make objects far away brighter, larger, anything that will make them easier to see, things that are very far away that you actually couldn't see with your normal eye, you often can with a telescope. Now, back in Galileo's days, telescopes, the strongest ones, really only gave you about 30 times zoom. At most, it was 3 to 30. So you could see things fairly well through them. They were decent, not at all like what we have now. Like with the Hubble telescope in space, we can see things so far away you couldn't even imagine seeing it back then. But what he did with this telescope, what Galileo did, was he used it to see the change in position of Jupiter's moons. 4 of them. Now, Jupiter's moons, he saw 4 of them. Which 4 did he see? Well, he saw Ganymede, Io, Callisto, and Europa. Those were the 4 moons he saw in his experiment. Now, if you were to take those moons and plot them, he did it in 4 different frames. He plotted them to show that they would change positions. His original drawings were not very detailed. It was really kind of just Jupiter here, big dot, smaller dot, medium-sized dot, and another kind of smaller dot. That was the picture he showed. And then when he went to the next frame right below it, the bigger dot was now here. The kind of smaller dot, or the medium-sized dot, was out here. The small dot from the left side is now over here. And the tiny dot is right here. So this one came all the way over here. This one came all the way over here. All the way over and all the way over. All of these dots moved in position. They were the same ones. He knew they were the same ones because he saw it in the telescope. But now they've gone all those different directions. So then in his third drawing, he had, once again, the really big one is all the way over here. The medium-sized one, or the next biggest, is over here. The smallest, the really tiny one, is out here. And the other small one, or the medium-sized one, is now back over here. So if you see a pattern, this one's curving outwards, this one's curving downwards, this one is kind of slingshotted around, and this one is also going down. Now, as this continued, you would see another pattern in here. One of them was going around in this shape. One's coming down like this. One of them is going real fast in the center. And another one's kind of going faster over here. That's the shape they're taking. They're taking a wave-like shape around Jupiter. He was noticing as he got more and more slides to this that he could see these curves better. And they followed almost this shape. If you were to put all the drawings next to each other, each one in different sizes would follow a shape similar to this, a sine curve, if you would. We call it a sine curve because in math, when you graph something like this, you would have this shape. This would be the center. And as it crossed over, it would invert itself each time. And if you were to take these two halves, so if you were to take this one right here and this one, put them on top of each other, it would be about a circle shape. It's the same thing with orbits. It was showing that orbits take on, and we know it's an elliptical, but at the time they would have almost put it as a circle. So all of these, they match each other, they invert on each other, and if you put them together, it would make a circle. So if you were to slide this one over to here, it would look like this. Now, what does that mean for we're not the center of the solar system sort of thing? Well, with that, they took into account the sun was so far away, and if Jupiter had things rotate or orbiting around it, we knew the moon went around us because it was in front of different things, but Jupiter was a lot bigger than the others, so the smaller things went around the bigger thing. Well, if the sun was a lot further away than Venus, Mars, the moon, Mercury, if it was further away than all these things, and we knew that, and it was so much bigger even though it was further away, well, it could be bigger than us, couldn't it? And the bigger object is what the smaller things go around. So that was evidence that if the sun was bigger than us, which at the time you couldn't see it with the naked eye, but through observations of plants and different things, they realized it was bigger, well then it would make more sense if we were going around it. That is what happens. The bigger things have the smaller things going around them. That's how space works. That's how orbits work. He proved, one, the shape of orbits going around Jupiter with these little pictures. It was literally just a circle with a few dots around it, and those dots would change positions. That's all the drawings were. He put them in a book, but that evidence alone was enough to completely change the way people thought about orbits and about gravity in space. So, if you have any questions about this, please leave a comment down below. Be sure as always to like the video so you can find it quicker and so I can know that you liked it. And as always, subscribe so you don't miss any more videos, and also so that you can find the channel a lot easier and let me know what kind of content you want to watch. Thank you as always, and I will see you next time.